Good morning, my dear students. How are you? Hope after the long vacation you are fine and well. Now you are the students of Standard 12. Welcome to your new class. Here I am to take your Chemistry 1 class. Today our topic is Autoionization and Ionic product of water. What is autoionization? You know, water is a weak electrolyte and it itself dissociates into positive hydronium ion and negative hydroxyl ion. This process is known as autoionization of water. Look here. Here, two molecules water together dissociate into hydronium ion and hydroxyl ion. According to Bronsted-Lowry concept, we know that proton donor is called acid and proton acceptor is called base. That means when acid dissociates into solution, then it donates proton and water acts as a base because it accepts the proton of acid. In the same way, when base dissociates in the solution, then base accepts proton from where base gets this proton from water. Here, water donates the proton to base. That means, according to Bronsted-Lowry concept, here water acts as a proton donor or acid. That means, water acts as both acid and base or proton donor or proton acceptor. Look, here two molecules of water. One molecule water accepts proton to make hydronium ion and another molecule water, it donates proton to make hydroxyl ion. That means this water molecule accepts proton. So it acts as proton acceptor or base. And this molecule water, it donates proton. So it acts as proton donor or acid. Here, one molecule of water acts as a proton donor or acid and another molecule of water acts as proton acceptor or base. Now, ionic product of water. What is ionic product of water? I have told before, water is a weak electrolyte, so it itself dissociates into positive hydronium ion and negative hydroxyl ion. The product of these two ions is called ionic product of water. That means the product of hydronium ion and hydroxyl ion is called ionic product of water. According to the chemical equilibrium, we get K equal concentration of product divided by concentration of reactant. That means concentration of hydronium ion into concentration of hydroxyl ion divided by concentration of water squared. Now, water is a weak electrolyte. So, it is slightly ionized into water. Due to slight ionization of water, the molar concentration of water may be taken as a constant. So, from this equation, we can write concentration of hydronium ion into concentration of hydroxyl ion equal K into concentration of water square. Both are constant, so they make a new constant, that is Kw. So, we get Kw equal concentration of hydronium ion into concentration of hydroxyl ion. That means concentration of both ions produced after dissociation of water. That Kw is called ionic product of water. This Kw, it has no fixed value because its value depends on temperature, and with the change of temperature, the value of Kw is also changed. But at 25 degrees Celsius temperature or at room temperature, the value of Kw equal 1 into 10 to the power minus 14. This is fixed for every aqueous solution where water is present. Value of Kw is 1 into 10 to the power minus 14. Now, effect of temperature on Kw. I have told that Kw changes with change of temperature. That means Kw is dependent on temperature. Value of Kw is constant at a particular temperature and changes with change of temperature. Autoionization of water is an endothermic process. Why? Because water is dissociated after giving heat. When heat is given, then water produces hydronium ion and hydroxyl ion. That means it is an endothermic process. Now, what do we know? For endothermic process, if temperature is increased, then reaction will go forward. That means for this reaction, when more heat is given, temperature is increased, more hydronium ion and hydroxyl ion will be produced and their product will also be more. So the value of Kw will be more with increase of temperature. Hence, with increase of temperature, molar concentration of hydronium ion and hydroxyl ions increases and Kw is also increased. In the same way, when temperature is decreased as an endothermic process, with a decrease of temperature, the reaction will go backward. That means the amount of hydronium ion and hydroxyl ion will be decreased. So, the value of Kw is also be decreased. Molar concentration of hydronium ion and hydroxyl ion in water. The molar concentration of hydronium ion and hydroxyl ion is equal for pure water. That means Kw equal hydronium ion concentration into hydroxyl ion concentration equal concentration of hydronium ion into concentration of hydronium ion. That is concentration of hydronium ion whole square. In the same way, we can write Kw equal concentration of hydroxyl ion square or concentration of hydronium ion and concentration of hydroxyl ion equal root over Kw. We know at 25 degrees Celsius temperature, Kw equal 1 into 10 to the power minus 14. So, after putting the value of Kw, we get concentration of hydronium ion equal concentration of hydroxyl ion equal 10 to the power minus 7. This is for pure water, that means for neutral water. Hence, at 25 degrees Celsius, in pure water, the molar concentration of hydronium ion and hydroxyl ion is equal, and that is 10 to the power minus 7 molar. We get for neutral water, concentration of both ion equal 10 to the power minus 7. But if water is acidified by adding small amount of water, then the value of hydronium ion will be increased. But we know that at 25 degrees Celsius temperature, the value of Kw remains constant, that is 10 to the power minus 14. So, if concentration of hydronium ion is increased, then the concentration of hydroxyl ion will be decreased. So, if we add a small amount of acid in pure water, we will get concentration of hydronium ion is greater than 10 to the power minus 7 and concentration of hydroxyl ion becomes less than 10 to the power minus 7. In the same way, if we add a small amount of base in pure water, then also the value of Kw remains unchanged, but the value of concentration of hydroxyl ion is more than 10 to the power minus 7. So, the value of concentration of hydronium ion is less than 10 to the power minus 7. Both ions, hydronium ion and hydroxyl ion, are present in all aqueous solutions, but all acidic solutions contain less amount of hydroxyl ion and more amount of hydronium ion, and all basic solution contain less amount of hydronium ion and more amount of hydroxyl ion. So, we can calculate the both ion, hydronium ion and hydroxyl ion of any solution by the following formula. If you want to calculate the concentration of hydronium ion, then hydronium ion equal Kw divided by concentration of hydroxyl ion, and concentration of hydroxyl ion equal Kw divided by concentration of hydronium ion. So, now using this formula, we can do some problem. At first, problem 1. The concentration of hydronium ion of a sample water is 3.2 into 10 to the power minus 6 molar. Calculate the concentration of hydroxyl ion and determine the nature of water. Their temperature is not given, so it is at room temperature. Here, the concentration of hydronium ion of a sample water is given. This water may not be neutral. You have to find out the concentration of hydroxyl ion. Not only this, after finding the both ion concentration, after getting, you have to determine the nature of water. That means the water is acidic, basic or neutral. Here given, since the sample water is at room temperature, so the concentration of the value of Kw equal 1 into 10 to the power minus 14, and concentration of hydronium ion equal 3.2 into 10 to the power minus 6. We know concentration of hydroxyl ion equal Kw divided by concentration of hydronium ion. Both values are given. So, after putting the value, we get concentration of hydroxyl ion equal 3.125 into 10 to the power minus 9 molar. And the concentration of hydronium ion is more than hydroxyl ion. The concentration of hydroxyl ion is 3.125 into 10 to the power minus 9 molar, and concentration of hydronium ion equal 3.2 into 10 to the power minus 6. That means the concentration of hydronium ion is more than hydroxyl ion. So, the sample water is acidic. Another problem. Problem 2. At 35 degrees Celsius temperature, the value of Kw of a neutral solution is 1.65 into 10 to the power minus 14. Look, here temperature is 35 degrees Celsius temperature. So, the value of Kw is also changed and it is 1.65 into 10 to the power minus 14. Calculate the concentration of hydronium ion and hydroxyl ion of that solution. The solution is neutral, so the both concentration will be same. There is given Kw equal 1.65 into 10 to the power minus 14, and we know Kw equal concentration of hydronium ion into concentration of hydroxyl ion. For neutral solution, both concentration is equal, so we get Kw equal concentration of hydronium ion whole square into concentration of hydroxyl ion square, or hydronium ion concentration and hydroxyl ion concentration equal root over Kw, and after putting the value we get the concentration of hydronium ion equal concentration of hydroxyl ion equal 1.28 into 10 to the power minus 7 molar. So today up to this is your first class in standard 12. So I will not discuss more today, but I will give you some homework. This homework you will get from the book, and it is from book page 483, exercise 4.43, 4.44a and 4.44b. These are very easy math, but you will do this math in your CW copy and you will submit it in the group. Now, next class we will come with some important and interesting lesson. Today up to this. Thank you everyone and goodbye everyone.